again. I have my radical notes up on the board. You guys might be laughing at home because you probably can see that I've already erased. I thought I was recording and wasn't, so this is take 2 for me. So this is definitely a learning curve, and let's see how this goes. So for radicals, you guys have definitely seen this symbol before. This symbol means that it's the square root of a number, meaning what number times itself is going to equal what's under that radical symbol. So if I were in school right now, I would say, what does the square root mean? Or what is the square root of 25? And everyone would tell me 5, that's for sure. Everyone knows that the square root of 25 is 5, and that is because 5 times 5 is 25. Now that we're learning about radicals though, we're gonna find that there are actually 2 answers to each square root that we have. And the reason being is positive 5 times positive 5 is positive 25. Now there's another number that when I multiply it by itself, it's also going to give me a positive 25. And that number is actually a negative number. There's going to be a positive square root and a negative square root for every square root that there is. So I'm going to add in a negative 5 in here, and that is because negative 5 times negative 5, remember a negative times a negative gives us a positive number. Now cubed root is a little bit different. A cube root looks like this. It's almost the same, but it's got a little 3 on the outside, and you're going to come to find out later in the lesson that that's actually called an index number. But for now, we're just going to know that it's a little 3, it's outside of the radical, and that means we're looking at a cube root. Now, a cube root, instead of a number times itself, we're looking for a number times itself 3 times. So this, the cube root of 125, the answer is actually 5. The reason being is 5 times 5 times 5 is 125. So I have 3 5s, it equals 125. Therefore, the cubed root of 125 is 5. If I break it down a little more, 5 times 5 is 25. And then again, 25 times 5 is 125. I should note here that there is not going to be a negative answer to a cube root. And the reason being is if I have, over here we did positive 5 times positive 5 times positive 5. Up here we had negative 5 as an answer for a square root. And the reason why that works is because a negative times a negative is a positive. Well, if we have negative 5 as our answer, negative 5 times negative 5 times negative 5, well, a negative 5 times a negative 5 does give me positive 25. But then what happens when I multiply by another negative? My answer is going to be negative 125, which is not what is originally under the radical here. So we have one answer, it's positive 5, and that's it. So moving on to perfect squares, the reason why we call these perfect squares is because I can take a block. I'm just going to sketch a 2 by 2 cube. So if I have a square, I shouldn't call that a cube, a perfect square. I sketched a square of 2 by 2. And when I find the area of that, 2 times 2 is going to be 4 units squared, right? What if I have a 3 by 3 block, a 3 by 3 square? Well, if I do 3 times 3, that's going to give me 9 units, 9 units squared for my area. So that's kind of the visualization behind that. And now over here, we're looking for what number times itself equals 1. Well, that's 1, and technically negative 1 as well. For the square root of 4, well, 2 times 2 is 4, which is where we get the answer 2 from. For the square root of 9, we have 3, because 3 times 3 is 9. The square root of 16 is 4. And I think you can see the pattern that's going to happen here. I'm just going to fill the rest in. 5 times 5 is 25. 6 times 6 is 36. The square root of 49 is 7. The square root of 64 is 8. 81, the square root of 81 is 9. Square root of 100 is 10. Square root of 121 is 11. And the square root of 144 is 12. So those are your first 12 perfect squares listed there for you. And now we're going to move on to perfect cubes. So over here we visualized using just a square. where the name perfect square comes from. And down here, we have some cubes for you. And I'm gonna start little to keep it easy. If I have a perfect cube, that means that all of my sides are going to be the same length. So if I have a cube with lengths of 2, and I told you to find the volume, everyone knows to do 2 times 2 times 2. And that gives me 8. I'm gonna write units cubed, make it official. So the cubed root of 8 is 2. Now if I come up here and do 3 by 3 by 3 cube, a 3 by 3 by 3 cube, when I multiply that out, I'm left with 27 units cubed. And I'm gonna do 5 over here. 5 is an easy number. 5 times 5 times 5 gives me a volume of 125 units cubed. So that is how I visualize what a perfect cube is. And now to list them out over here, I have the cube root of 1. Well, 1 times 1 times 1 is 1, which is why we say the cube root of 1 is 1. For the cube root of 8, I have 2 times 2 times 2. That means the cube root of 8 is 2. For the cube root of 27, again, I'm looking for what number times itself 3 times equals what's under that radical. So for me, I know it's going to be 3. Again, there's a pattern happening here. You guys probably already see that at home. The reason why my answer is 3 is because 3 times 3 times 3 is 27. And I'm going to fill in the rest of the pattern here. We've listed the first 7 perfect cubes for your notes. And that is basically the background information for radicals. Next, we're going to move on what the parts of a radical are, and we're going to be simplifying radicals for you. So the first thing that I want to note is up here, we have a 6, we have a radical, and we have a 5. So if I were to say this out loud, I would say 6 root 5 is how I would say that. And what that means is 6 times the square root of 5, right? When there's no symbol in between, we have a multiplication symbol. So that's what that means, 6 times the square root of 5. And you've also probably noticed, like I had said back here, sometimes there's going to be a little number outside, that's called the index number, and sometimes there's not. So over here, we have a little note box for you that says a radical without an index number is assumed to be a square root with an index number of 2. So when I was just talking about 6 root 5 over here, really there's an invisible 2 hanging outside of that square root of 5. That's going to come into play when we're simplifying in a minute. And for parts of a radical, the little number on the outside is called an index number. The whole thing is called a radical, all the parts combined. The symbol, just like we started with the perfect squares over there, the symbol itself is called the radical symbol. And the number underneath is called a radicand. So those are the parts of your radical. And for the next part, I'm actually going to move into my bathroom. Amongst all your teachers, it has become pretty known that writing on the whiteboard is not possible right now. So writing on the shower, the side of the shower, apparently works. So we're gonna try this out. I wanted to be able to make it bigger for you and maybe change it up a little bit. So we're going to start by simplifying the square root of 54. So let's hope this erases well. I tried it before and it was working okay. So I have the square root of 54. If you're following along with notes at home, it's this top left one. And as you know in class, we always type out the steps for you, but we typically teach by example first, and you can go back to the steps if you need it. But step 1 says make a factor tree. Now you've been doing this for a few years now. Everyone knows how to do that. For the square root of 54, I'm going to break that down into 9 and 6. And now there's many different ways to break this number down. I'm not going to worry about it. You're just going to do it your own way, and someone might do it differently. If we were in school, the person next to you might do it differently. You're going to end up with the same thing no matter what. As long as you're doing it correctly and you're using the correct factors along the way, it doesn't matter kind of how you go about it. So I have 9 and 6 for now, and 6 can break down more. It can break down into 3 and 2. So for 3 and 2, I'm going to circle those. I like to call those the leaves of my tree. They're my prime numbers. They can't break down anymore. I'm going to circle them and go back to them later. And then for 9, I'm going to break that down into 3 and 3. And again, I can circle those, and I'm going to come back to them later. So for my steps, if you're looking at the notes, it tells me to determine the index of the radical. Well, the index was that little number out here, and there isn't one here. If we were in school, I would ask you to look back up at that note, and I would want to know what we said when there's not a number there, what we assume it is. I'm going to tell you now we assume it's a 2, and that means I need to group 2 of a kind. So I like to say that they're going to play outside. So I need a group of 2. I need partners to play outside of the radical. Well, I see 2 3s. I'm going to cross them out, and they can come outside of my radical. And it comes out as 1. They're such close friends that it comes out as 1. So both of those 3s I've dealt with. And now anything that does not have a friend, they're stuck inside, kind of like us. We're stuck inside. They can't go out and play. It's not safe. So I'm going to keep a 3 times a 2 on the inside. So when I multiply 3 times 2, I'm left with 6. So I have 3 root 6, and that is my answer. I would be done there. So we're going to keep going. If we were in class, you'd all be saying, I don't get it. We're going to do 6 of these together, so you'll get it by the end of the video. And if you're not understanding still, then we have those office hours tomorrow for you. So the next example we're going to be doing is the square root of 160. So I'm just going to write it out, pray that it erases later. So I have the square root of 160. I'm going to factor tree first. Step 1, factor tree. So I'm going to factor tree this with a 16 and a 10. You could break it down differently. You're going to end up with the same leaves at the bottom of your tree. So I have 16 and 10. I'm going to keep breaking those down because none of them are prime. 10, I'm going to break to 5 and 2. And I'm going to circle those. Those are now leaves. They're prime numbers. I can't break them down anymore. And for 16, I'm going to break that down into 4 and 4. You might do 8 and 2. You're going to end up with the same leaves again. So for this example, I'm going to do 4 and 4. And each 4 breaks into a 2 and a 2. And those are prime. I can't break those down anymore. 2 and 2. Now I do not have an index number. We are assuming that that's a 2, and I need to pull numbers out in groups of 2 to play outside. So here I have 2 2s. That's going to come out as 1. I see another group of 2s, and that's going to come out as 1. And last but not least, I have a 5 and a 2. They don't have a friend. They don't have a match. There's not another 5 to play with that 5. There's not another 2 to play with that 2 because these guys are already buddies. So I'm going to keep those inside of my radical symbol. I have a 5 and a 2 left. And then I'm just going to simplify what I have. 2 times 2 leaves me with 4. And 5 times 2 leaves me with 10. So that would be my final answer. I would be done. The next one. This one looks a little bit different. I have 2 times the square root of 63. So that goes back to this example up top here when we said that means we're multiplying it. So when I do a problem like this, I like to write it out first. I'm going to write 2 root 63. And off to the side, I like to write that big number out so I don't forget about it. I'd like to come back to it. So I'm going to write a 2 over here. I know that's already playing outside. I don't want to forget to multiply it into those outside numbers later. So I like to just jot it down over there. And then I'm going to break down 63. 63 can break into 9 and 7, neither of which are prime. 7 is prime. I'm going to circle 7. 7 is a leaf. It's the bottom of our tree. And 9 breaks into 3 and 3. Now I'm going to go find, again, there's no index number here. There's no number, so I assume that it's a little 2. And that little 2 means I need groups of 2. So I have a 3 and a 3. They're also going to play outside. I had 2 of them, so I can group them up and they can play outside. And the 7 doesn't have a friend. The 7 is stuck inside still. I'm going to keep it under that radical symbol and then just simplify what I have. So I have 2 times 3 is 6, and my root 7 just stays under the radical there. I'm running out of space a little bit, so I'm going to switch colors so we don't get smushed together. We'll move on. We'll use some pink to do the bottom row. This one is different, just like the one up top. It was a little different, but it's different for a different reason. Here I have an index number. They give me that number. So when they give me that number is super important. I need to really pay attention to that and take note of it and use it throughout the problem. So first I'm going to just write it out. I have, I would say, this cube root of 120. And I'm going to just start with a factor tree like I would for every other problem. Step one is just always a factor tree. I think the easiest way to break this one down is going to be 12 and 10. My 12 can break into 6 and 2. I'm going to circle my 2. It's prime. I can't break it down anymore. And the 6 can break into 3 and 2, both of which can be circled. I'm going to come back to my 10 now, and 10 can break to 5 and 2. I'm going to circle both of those. They're prime. So this is my factor tree. Now when I'm pulling numbers out to play outside, or I said grouping in twos, playing outside with your friends, I had referenced before. Now I have a little 3 that I have to pay attention to. When that index number is a 3, that means I need to find 3 of a kind to play outside. So I'm going to come down here and I see 3 2s. I'm going to cross them off. 1, 2, 3 of them. Because there are 3 of them, they can play outside. Now I have a 3 and a 5 left, neither of which have any friends at all. They need to stay in the house. They need to stay under the radical. So we'll say 3 times 5 here. Now 3 times 5 is 15, so my final answer is going to be 2 root 15. Oh, little fib. Technically that answer would not be right. And the reason why that's not correct is because when I have an index number that's given to me up here, I need to include it in my final answer to be correct. With these other ones, when I did not have an index number given to me, you don't need to write that little 2. If you wanted to write the little 2, you could, but you don't have to. When it's a 3, 4, 5, any other number, you do have to write it in your final answer. So we're going to move on a little bit further. We have 2 left here. We have the cube root of 320 next. I'll switch up the color for you guys again. So the cubed root of 320, I'm going to write it out. And this one's just like the one we did in pink. I'm going to start with my factor tree again. I'm going to do 32 and 10. If you break it down differently, that's okay. You should end up with the same circles or the same leaves at the bottom of your factor tree. So I have 32 and 10. My 32 can break into 8 and 4. My 8 can break into 4 and 2. 2 is prime, I'm going to circle it. 4 can break into 2 and 2. I'm going to circle those as well. And I'm going to come back to this 4 because I did not deal with that yet. That 4 can break into 2 and 2. And the 10 can break into 5 and 2. Now I have a lot of leaves here, so I'm going to take my time with figuring out what's going on. I'm going to look back to my index number. The index number is 3. That means I need 3 of a kind to pull them out. So I have 3 2s. 1, 2, 3. They are coming outside and they are becoming 1. So I have a 2 on the outside. Now I'm going to look back at the rest of the leaves that I haven't dealt with yet. And I have 1, 2, 3 2s again. So I'm going to cross those off. And they can also play outside. Now I have a 5 left. No friends. That 5 is stuck inside the house under the radical symbol. He cannot come out to play without a partner or a group of 3. So I have 2 times 2. I'm going to make that a 4. And I have a root 5 on the inside. And this is not done yet. We are not done yet because I need to include my index number. My index number is a 3. And then I would be done. All right, guys, I have 1 left, and this is a challenging one. We only have 1 of these on the worksheet for you for tomorrow. This one is different because the index number is 4. If we were at school, somebody would yell out, well, that means we need a group of 4. And you're right. Hopefully you guys were thinking about that at home while you're watching this. When we had an index number of 2, or like an invisible little number, we assumed it was a 2. We needed partners or groups of 2 to come outside. When we had the 3s in the last 2 examples, we needed a group of 3 to pull it outside. With the 4, we need a group of 4. So I'm going to go up high for this one. We have, write out our problem, we have an index number of 4. And under the radical we have 2,000. So I'm going to start off by breaking that into 20 and 100. That 20 and 100, I'm just going to break down all the way, same rules as the rest of them. I need to make a factor tree all the way down to the prime numbers or the leaves. My 20 is going to break into 4 and 5. 5's prime, I'm going to circle it. 4 breaks into 2 and 2, and I can circle my 2's. 100 can break into 10 and 10, and each 10 can break into 5 and 2. So now that I have my whole factor tree, I need to find a group of 4 to pull that number outside. So I have 1, 2, 3, 4 2's. So I'm going to cross those off so I don't forget that I used them. And that 2 can play outside. It becomes 1. Now the rest of the numbers, I don't see any more groups of 4. I see a group of 3. I have 3 5's, but I don't care about that because my index number is now a 4. So all of those 5's need to play inside separately. So when I multiply this out, I have 5 times 5 times 5, which is 125. And again, I'm not done yet. I need to make sure I include my index number. My index number here is going to be 4. And that would be my final answer. So I hope this was helpful, guys. Tomorrow for now, you're going to go down to the bottom of the Google form and just answer how you feel about what we just did on my bathroom wall. And then tomorrow you're going to practice a little more. And if this was a little daunting for you, then call into those office hours. I'm happy to help, and we can kind of go back and forth with questions and answers. I can't wait to see you guys tomorrow. Bye.